Welcome to the next lecture, this time very short one, a brief introduction to the Kedro framework, which is gonna be a basis key framework for us to implement machine learning pipelines in Python. So when we look at the place of this lecture in our course, we are here in still core processes. This time I'm gonna show you in a set of practical sessions how to implement Kedro for pipelines. You have all the code necessary to run these examples in my folder, but also you can easily follow very good tutorials on the Kedro itself. We are going to work with the example from Dataiku as a basis for our code. We are going to use the Python implementation of this pipeline. Let me remind you, this is a simple machine learning project where we are going to use binary classification to predict whether a new customer will or will not be a high revenue customer for us. This is the example of e-commerce store which sells t-shirts online globally, and as input for our training dataset we have customers data about some demographic features like gender, age, etc., and some behaviors like the computer used to log in, etc. And secondly, we have some orders data where we have data about separate orders by each customer. Next, we perform a set of different data prep procedures, end up with some training dataset, and make a training binary classification model training and deploy this model to production. We're going to implement this example in our Kedro framework. Kedro.org is one of the most popular frameworks for machine learning pipelines. It is fully open source, so you can use it free of charge. It's developed by a very good community. And moreover, it's commonly used by different companies to implement the real machine learning scenarios. It's a kind of the alternative to very complex tools like TensorFlow Extended, which we're going to cover in some part later on. I strongly recommend you to get familiar with this code. It's not only because it's quite popular among the production teams, including my friends who do really large projects with this framework, but it's, in my personal opinion, also very beautifully written and very well documented. So I have a very good satisfaction with when I observed how it evolves. So before we go into the technical details, let me briefly introduce you the general idea behind this software. In the first step, we set up the project on our computer. Next, we set up data sources for this. That may be a local file or some data in the cloud. We have many different connectors, including streaming data. Next, we create a pipeline and package the project for deployment. So we can do all the lab work on our local computer and later then package this to firstly run on the hosted machine somewhere, but also it has a very good interfaces to Kubeflow, so we can export this project and implement this directly on Kubernetes cluster. And so in this first stage, and it is also covered by in my example files, we'll set up the project, we'll create a new project, install dependencies, and configure the project. In setting up the data, we'll add the data to the configuration file and register the data sets. Next, we'll create the pipeline. We're going to use the pipeline template, create nodes, assemble nodes into the pipeline, test and visualize the pipeline, persist artifacts if we need that, but it's generally a good idea, and modularize the pipeline. And finally, we will package the project, document this, and deploy it somewhere. Very interesting idea behind, which is heavily used by Kedro team, is so-called data engineering convention. So when you are going to set up and the data for your project, you'll have different types of data. We're going to have the raw data, intermediate data, primary data, features. That follows the typical stages of data prep. Raw data may be just simple data from sensors or from our databases. Intermediate are the data after the cleaning. Primary features, there are many different definitions in the data engineering convention. And next, finally, when we have those features engineered, we may have a model input and models. And model output, if you make the inference. As you can see, there are many different types of data. It's good to follow this convention, some data for reporting, before we delve into the real Kedro project. And okay, so I think that's a very good practice from Kedro to follow this convention. You obviously do not need to define precisely all those types of data. In many cases, in many projects, that may be overkill. So for your case, I would definitely suggest to use raw data. Next, features, which may be the same as model input. Next, models, model output for sure. And if you would like to track the and monitor the project on production, reporting also. So when we run the Kedro, when we have everything configured, we can run the pipeline. As you can see on this computer, this is a print screen from my computer. So it starts with loading the data. So this is the first component. Then if we want to persist the data, it will save it to the computer. It may be saved or loaded either from some physical data sets if you persist the data, or from the memory if you do not want to persist. We may use many different formats. It may be comma separated value, that may be Parquet data set, etc. Next, as you can see, it tells us different stages in the process of data prep, and finally model training, saving the classifier as pickled data to the drive, and then finally evaluate the model, and that's all. So that looks like that, but that's obviously the print screen, print out, apologies, but we may also automatically ask Kedro to visualize such a pipeline for us using Kedro Viz. This is a separate package. So as you can see, it can run the web service on your local machine, but you can obviously deploy the service wherever you want. And this is very useful for firstly managing the complex pipelines. What you can see here is extremely easy pipeline, but believe me, in large real-life projects, those pipelines are really complex, so we need to take care about different libraries and the interconnection between them. And here, as you can see, we have a show code option. So for each component, we can see the code itself. So it's good for managing the code, but also to present the structure to your business user, because business users usually do not understand the code itself, but they want to understand the flow of the data. So that's also very powerful. And you have also very nice libraries for building documentation for your project. As we mentioned in the previous lecture, if you write your documentation within the Python code, it may generate automatically the documentation for your pipeline. So this is the website. If you click this website, as you can see here, you will be redirected to the documentation. What I can suggest you is obviously to go through the first step, set up Kedro, and next create a new Kedro project, go through the key concepts. But later then, I think that the best way for you would be to follow this tutorial, set up a Spacelight project, this one. This is a very good example and will take you through all the key steps in Kedro. So you will find this example applied to our case studies on my drive in the folder shared with you, but I strongly suggest you to go through this. It will take you approximately 2 hours. I do not include here some potential complications with the Kedro installation or some dependencies. It should go smoothly, but it's not always the case. So here we have not only the tutorial but also other information about the data catalog. This is very interesting for you. And here, as you can see, we have also a very interesting section on the deployment on the single machine, which we are going to use in our course, but also distributed deployment with different cloud providers, including, as I mentioned, Kubeflow pipelines. So this is it for Kedro, and the next steps is on the side. Do your best to implement your simple project in Kedro as the beginning of your journey in ML DevOps. Good luck.